Hi everyone, I'm Balaganesh, and this is a continuation from my first lecture on the topic of inverse trigonometry, which is intended for class 12 CBSE students. So let's get started with the new lecture. So to recall, in the last lecture, we discussed about the conditions for invertibility of a function, and also then we discussed the domain and the range of all the inverse trigonometric functions, and solved some simple problems based on them. So I want to once again recap the definition of the inverse of a function. Like if you have a function f from set A to set B, then the inverse function f inverse is defined from set B to set A, satisfying these two properties. F inverse of f of x equals x for all x belonging to A, and also if f of f inverse of x y equals y for all y belonging to B. So in fact, these two parts of the definition are very important. That is, it is satisfied only when x belongs to A and when y belongs to B. So you might think that the inverse trigonometric function will always just cancel out the corresponding trigonometric function, and the result will have no effect on whatever value is being operated on. That is, you might be inclined to think that sine inverse of sine theta is equal to theta, right? But this is not true for all values of theta, because if you recall, sine inverse is defined from -1 to 1, and here the range is minus pi by 2 to plus pi by 2. So if you compare this with this, we see that this is the set B and this is the set A, isn't it? So then you have, so that means this relation corresponds to this relation over here, and it is valid when theta belongs to the set A. And what is our set A here? This one. So this is valid for theta belonging to minus pi by 2 to plus pi by 2 only. And similarly, sine inverse of x equals x when x belongs to the set B here, because this is f of f inverse, right? So what is the set B? -1 to 1. So the question naturally arises, what happens if theta and x do not belong to these mentioned ranges? In the second case, it is pretty straightforward. You know that sine inverse is only defined in this interval. It is not defined at all elsewhere. So that means this expression will become undefined if x is outside this interval. That is sort of straightforward. But what about this case? Sine theta, you can take the sine of practically any angle. You can take the sine of any angle outside this range also. But in that case, this identity will not hold. It so in fact, that means in this case, the sine inverse of sine theta will be defined, but it will not be equal to theta if theta lies outside this range. So the question is, what exactly is the value of sine inverse of sine theta when theta does not belong in this range? So to do that, you need to reduce this expression into a different form, such that it will be expressed in a different terms of a different angle, say phi, and phi will be in this range. So that we will see in the problem, in some problems that I'm going to solve. But before that, one more remark. This identity sine inverse of sine theta can be generalized for all the other inverse trigonometric functions. But here, that is, we will, but so you can say cos inverse of cos theta is equal to theta. But in this case, the value in the range of theta for which it will be valid is the principal value branch of cos inverse, which we have defined earlier. So that means theta must be between 0 to pi. So, and similarly, tan inverse of tan theta equals theta only when theta belongs to its tan inverse's principal value branch. and so on and so forth. So as our first example, let us consider what is the value of cos inverse of cos of 7 pi by 6. Now the principal value branch of cos inverse is 0 to pi, and this angle does not lie in this principal value branch, isn't it? So you cannot just directly cancel out the cos inverse and cos and say that the answer is 7 pi by 6. That's wrong. So we need to reduce the expression to the form cos inverse of cos phi, where phi is some angle that lies within the principal value branch. That is, phi belongs to this range, isn't it? So to do this, we need to rewrite this cos in terms of the cos of another angle. So one way to do that, let us recall the identities from trigonometry. We have cos of pi minus theta, and that is also equal to cos of pi plus theta, which is equal to minus cos theta. So this is fine, but this will not be suitable in our case, because if we use this identity, we'll pick up this additional minus sign over here, and it will not become of this form. We need to reduce it to cos inverse of cos phi, not cos inverse of minus cos phi. So we use another identity. We could use another identity, cos of 2 pi minus theta, that is equal to cos theta. So let us try using this identity on this in this expression. So if we call this 7 pi by 6 as theta, then we can write cos inverse of cos of 7 pi by 6. This is equal to cos of 2 pi minus theta. Cos inverse of cos of 2 pi minus 7 pi by 6. Now this is 12 pi by 6 and this is 7 pi by 6. So it will become cos inverse of cos of 5 pi by 6. And now you see you've reduced it to this form, cos inverse of cos phi, and this phi angle or 5 pi by 6 that we got here is within the principal value branch. So that means now we can directly cancel out the cos inverse and the cos and write our answer as 5 pi by 6. So let us look at another example now. We want to find the value of sine inverse of sine of minus 600 degrees. So obviously the first step that you need to do here is to convert degrees to radians, and the conversion factor for degrees to radians is pi by 180. So you write 600 degrees is equal to 600 into pi by 180. And this one will be 10 and this is 3. So it is 10 pi by 3. So that means this expression will reduce to the form sine inverse sine of minus 10 pi by 3. Now we can rewrite now again this minus 10 pi by 3 is not within the principal value branch of sine inverse, which is minus pi by 2 to plus pi by 2, isn't it? This is clearly outside that range. So we want, and so basically this angle is in magnitude it is slightly more than 3 pi. So we need to keep that in mind when simplifying it. It is a pretty large angle in magnitude. So with that in mind, we can write it. We can first take this minus sign outside the sign using the identity sine of minus theta is equal to sine minus sine of theta. So you can write it as sine inverse of minus sine 10 pi by 3. And also, as a side note, you can remember that sine of pi plus theta is equal to minus sine theta. And now since sine is a periodic function whose period is 2 pi, that means we can add 2 pi, any multiple of 2 pi to the argument on either side of this expression, and the identity will still hold. So if we add 2 pi over here to this side, we end up getting the identity sine of 3 pi plus theta is equal to minus sine theta. So, so what we can do in this expression now, with this identity here in mind, is that we can write this as sine inverse of minus sine of 3 pi plus pi by 3, because this is straightforward, because 3 pi is 9 pi by 3, and if you add one more pi by 3, then it will become 10 pi by 3. So, and now we have 3 pi, and sine of 3 pi plus theta. This will become minus of sine theta. So we get sine inverse of minus of sine pi by 3. These two minus signs will cancel, and we are left with sine inverse of sine pi by 3. And pi by 3 is in this interval. So that means we can now cancel out the sine inverse and the sine and write the final answer as pi by 3. So these two were relatively straightforward, but this next problem which I'll do is going to reinforce some of the concepts that you learned in trigonometry 11th grade as well. So in this question we are expected to simplify the expression tan inverse of cos x by 1 plus sin x. And here they have given a range on the value of x, that is, it ranges from minus pi by 2 to plus pi by 2, both exclusive, like this. So it is very likely you would have encountered expressions of this kind many a time in 11th grade trigonometry. Only thing is that it would have been in a slightly different form. That is, you would have had something of like sine x, sine y by 1 plus cos y, and if you use the multiple angle formulas in the numerator and denominator, you'll end up getting 2 sine y by 2 cos y by 2, and this is equal to 2 cos square y by 2, isn't it? So, and after you cancel out all the factors, you end up getting the answer as tan of y by 2. So coming back to this problem, there are multiple approaches of solving it, but one of them makes use of this kind of a motivation. But if you see here in the numerator you have sine, and in the denominator there's 1 plus cos, but here it is the other way around. So the first step we need to do is convert cos to sine and sine to cos. Now that can easily be done if we replace we write cos x as sine of pi by 2 minus x and sine x as cos of pi by 2 minus x, like this. Tan inverse of it will be sine of pi by 2 minus x by 1 plus cos of pi by 2 minus x. Now for simplicity, let us call this pi by 2 minus x as y. So we can, this is equal to tan inverse of sine y by 1 plus cos y. So now if you follow this simplification over here, then we'll end up getting tan of y by 2 in this bracket. So we'll get tan inverse of tan y by 2. This will be, and y, since y is pi by 2 minus x, y by 2 is pi by 4 minus x by 2. So that will be tan inverse of tan pi by 4 minus x by 2. And as before, do not directly cancel out the tan inverse and the tan and say that the answer is pi by 4 minus x by 2. First, before you do that, you verify that this angle over here is in the principal value branch of tan inverse here. The tan inverse principal value branch, if you remember, is minus pi by 2 to pi by 2. So, so how do we find the range of this angle here? That is fairly straightforward. You use this inequality that they have given here. Minus pi by 2 is in x less than pi by 2. And now we need x by 2 here. So we divide this entire thing by 2. We get minus pi by 4, then x by 2, then pi by 4. Now this has a minus sign in front. So we multiply everything by minus 1 and the inequalities will flip. So you get pi by 4 greater than minus x by 2 greater than minus pi by 4. And if you rewrite this inequality in a different way, you get minus pi by 4 less than minus x by 2 less than pi by 4. And now the last thing is just to add pi by 4, and then whatever will be here in the center will be this angle. So if we add pi by 4 everywhere, we get this one will become this one will become 0 by 4 minus x by 2 less than pi by 4 plus pi by 4 is 2 pi by 4, which is pi by 2. So yeah, so you can see that this angle lies in the range 0 to pi by 2, both exclusive, isn't it? And that is a subinterval of this principal value branch. So that means in any case, this value will lie within the principal value branch of tan inverse. So that means cancelling the tan inverse, and the tan is justified in this case, and we can directly write the answer as pi by 4 minus x by 2. So with that, we complete the second lecture in the inverse trigonometry series for class 12 CBSE. So in the next lecture, I will again be discussing a couple more advanced problems, and if possible, I will cover some new identities as well. So thanks for watching this video, and bye for now.